have to assume that. Now, if you assume the other customers are malicious, then you think, what is protecting me from the other customers? Down here, it is typically the hypervisor. So while virtualization is not new, we are using virtualization down here as our frontline security defense, just like an enterprise firewall. Given that hypervisors have between 200,000 and 1 million lines of very complex code, chances are there's a vulnerability. I created the US National Vulnerability Database. In the years that I ran it, pretty much all software had vulnerabilities. So, there's a security issue there. But we're not here to solve the security problem, thankfully. Let's see, deployment models. There's private, community, there's public clouds. They all serve their purpose. As you go down to public, you're likely to get a greater economy of scale. As you go down to private, you're likely to get less threat exposure. I'm actually a believer in micro clouds, less than 100 servers all resource pooled together. Yeah, you don't get the huge economies of scale like a Google or an Amazon, but you do achieve some resource pooling, you do achieve some cost savings, increased capability. Let's see here. And we don't have time to discuss hybrid, so we won't. So which is more secure? Well, none of them. Threat exposure, there's greater threat exposure here, there's less there. There might be more security resources here than here. So which is more secure remains to be compared on the actual implementation. So that you don't think I'm an idiot, here are some common cloud computing characteristics. But they're not necessary. They're not definitional. But you should keep them in mind. Now, instead of discussing them, I'm going to show you a picture. This kind of puts it all together. And the definition, I'll put up the link afterwards. It's just a short 2-page definition that puts all of this together. And then the NIST Cloud Pub talks about some of those. Okay, so now a different story. So I've told you about cloud computing. After I stopped doing cloud computing, I sat in my office and twiddled my thumbs, literally for about 2 weeks, and thought, what should I do? I have a weird job, don't I? My management doesn't always give me things to do, but they expect the world of me. So there's lots of pressure. But I started looking at continuous monitoring. And DHS had created a continuous monitoring architecture. Basically, the federal CIO went to DHS and said, we need to solve the security problem. A big piece of that is continuous monitoring. Please go out within the civilian government, find people who are doing it the very best, and abstract their solutions to come up with an architecture that the US government can use. So that's what DHS did. They did a good job. They were sort of first horse out of the gate. And so you wouldn't expect their solution to be perfect. But they did go in the right direction. That fall, it was last fall, last September, the ISMC, the Information Security and Identity Management Committee, which is under the Federal CIO Council, they created a subgroup on continuous monitoring. And by the way, this work supports that subgroup as one of their 3 or 4 main mission elements. It supports federal network security, homeland security. It was responsible for continuous monitoring for the government. And in those meetings, we looked at the DHS architecture, and we said, this is great, but there are some limitations. So the paper here talks about the limitations and talks about a way forward, a way to do this differently or better. We wrote it with DHS, we wrote it with NSA, so that it's not like we're competing here, the government is actually working together. Should I say that again? We're actually working together. So it's a neat thing. It's a good project. So here's where I'm going to give you a very quick overview of our published thinking. This is the thinking that was published in this draft Caesar's Framework Extension document. That thinking has matured, and a variant of that will be published hopefully in the next few months. We've promised the ISMC a complete specification by the end of October, so that's when we're really nailing this down. And we're not trying to provide high-level guidance here. We're trying to solve a real problem. How do you take a diverse set of security tools, and how do you aggregate that data together? How do you normalize that data? How do you apply your policies so that you can score it and understand that data? But then, how do you aggregate that data up through multiple tiers in the organization? Where as you go up multiple tiers, you're supporting different levels of decision making. So at the lowest tier, you're supporting the operations staff. You're actually supporting the operations staff. This is not a compliance exercise. And as you go up tiers, you're supporting higher level decision makers. And then you might be supporting the U.S. Cyber Command. And you might be supporting Department of Homeland Security's view. And at the end of the day, I haven't asked him, but I'm quite positive that the federal CIO would want a nice dashboard showing the status of all the agencies and their security posture, but not some sort of graded report on handwritten documents. This is a mathematically defensible quantitative assessment of agency security. Can that be done? The answer is yes. Is this a hard problem? Yes. Do the vendors provide us the solutions we need? Yes, but. And a lot of what we're looking at is what vendors don't do well. We're trying to specify that, possibly standardize that, push that out to industry, enable government to procure those products so that we have the capability, a unified capability for the entire federal government. Does this sound crazy? Yes. Have we done it in the past successfully for security automation? Yes. Is it perfect? No. So in a way, we're following the SCAP model, but we're doing something very, very different here. We're starting with a definition of continuous monitoring. Like cloud, we're pulling out essential characteristics. I don't have time to discuss the maturity model with you. We've got an enterprise architecture for what's supposed to happen. We've decomposed this into subsystems we need, to technical models with interfaces between the subsystems that we need. We know the workflow that has to occur within any system that does continuous monitoring, which leads us down to specifications that vendors could actually build to, interfaces, and payloads. So at the end of the day, we're specifying things that can actually be built to. So here's a general definition, which I'll just let you read. This is an NSA definition. I did not write this. I like this definition because it doesn't mention security. Continuous monitoring is about more than security. In fact, what I'm trying to do is very difficult. I'm not trying to specify a continuous monitoring system. I'm not trying to specify a single thing for the government to buy. I'm trying to specify, and stay with me here for a second, this is going to sound strange. I'm trying to specify requirements for doing continuous monitoring regardless of the data that you're going to monitor. So specify requirements for products that products can build, that they can actually build to, that describe workflow, that they'll